Hello ladies and gentlemen, we are going to do more work with our graphing of rational expressions. So we're going to graph some higher degree rational functions and then state their domain and range. Alright, and so just to remember, a rational function is going to be f of x is equal to one polynomial divided by another polynomial. Okay, so that's what a rational function is. Alright, so I want to talk to you about the rules again, just as a reminder. So when I'm looking for my vertical asymptotes, the vertical asymptotes come from the denominator. It's whatever makes the denominator 0, because we can't divide by 0 because the world explodes. So my vertical asymptotes are always going to come from the denominator. My horizontal asymptotes, on the other hand, come from, are determined by the degree of the two different polynomials. If the degree of the denominator is higher than the degree of the numerator, then the horizontal asymptote is going to be y is equal to 0. If the the degree is the same in the numerator and the denominator, hang on just a sec, then my horizontal asymptote, sorry about that, is going to be the quotient of my two leading coefficients. And if the degree in the top is higher, then we actually do not have any horizontal asymptotes, and we'll talk about what happens later. Alright, so those are just a review of what happens. Okay, as with all graphs, we often want to label our x-intercepts. The x-intercepts are found in the numerator. We can solve the numerator for x, and then that becomes the ordered pairs for our x-intercepts. Okay, and then my y-intercepts always come from letting x equal 0, and then we solve for y. Okay, alrighty, and then my branches, we are going to use our graphers to help us a bit, so I'm actually going to be showing you some graphs today. So most of what we're going to do is graph by hand and then state the domain and the range, and we're going to use our graphers to help us with our curves. Alright, so let me scoot this up a bit. So let's just start right in with an example. Okay, and it's going to say, they're all going to say the same thing, graph, and then state the domain and the range. Okay, my equation is going to be y is equal to 6 over x squared plus 1. So the first thing that we usually do is try to find our vertical asymptotes. So notice if I'm working on my vertical asymptotes, I would set x squared plus 1 equals to 0, and then I solve x squared is a negative 1. Well, if you notice, because this is a negative 1, when I take the square root of both sides, I would get x is equal to plus or minus 1i. And if you'll remember, when we talked about complex numbers, they do not show on our graph, so there actually are no, I'm going to write none, no vertical asymptotes. Okay? Alright, so now let's talk about our horizontal asymptotes. So if you'll notice, the degree in the denominator is higher. The degree for the denominator is a second degree. And remember, technically, the degree in the numerator is 0, because anything raised to the 0 power is 1. So my numerator has a degree of 0. So because the degree in the denominator is higher, my horizontal asymptote is going to be as y is equal to 0. Okay? The 6 in my numerator is going to be my y-intercept, sorry. So if I let x be 0, I'm going to get 6 divided by 1. Okay, so I'll write that down. So if I let x equal 0, which is how I find my y-intercept, then I'm going to get y is equal to 6 over 1, which is 6. So if I sketch my graph, and I'm actually going to use my grapher to help me on this one because it looks a little bit weird. I'm going to label this point as 6, 0. I know that I have a horizontal asymptote at y is equal to 0. And my graph is actually going to do something kind of like that. It's kind of cool. So let me show it to you. Okay, and then we'll talk about the domain and range. So I'm going to scoot it over. So if I go to my y equals and I clear all that stuff, and I do 6 divided by, and I put my entire denominator in parentheses, and I graph. There's my graph. Pretty cool looking, right? Okay, so now let's talk about the domain. Since there are no vertical asymptotes, then my domain is going to be all real numbers. Okay? And remember, I can write that as negative infinity to positive infinity. My range, I have a horizontal asymptote at y is equal to 0. My range is red from the bottom up, so my range is going to be from 0 to 6. Okay, and the 6 is included. Oh, bad me, I wrote that wrong and nobody caught that. Whew, sad day. The 6 is included, so there's the included, and the 0 is not included, okay, because I have a horizontal asymptote at 0. Remember that a square bracket means that the value is actually included. So now what we're going to do is just a series of examples with graphs, okay? All right, so let me do our next example, okay? So this one, same thing. It says to graph, state the domain and range. So my equation is going to be y is equal to 2x squared over x squared minus 9. And we're actually going to do this one by hand first, and then we'll confirm it with our calculator. All right, first thing I want to do is factor the denominator. This is a difference of two squares, so it's going to be x plus 3 and x minus 3. Okay, so right off the bat, I know that I have vertical asymptotes of y is equal to plus or minus 3. I have two vertical asymptotes. Notice then that the degree in the bottom is 2, the degree in the top is 2, so my horizontal asymptote is going to be y is equal to 2 divided by 1, which is 2. And I'm going to put that information on my graph, okay? So I'm going to have a vertical asymptote at a negative 3, one at a positive 3, okay? And so this is x is a negative 3, and then this one is x is a positive 3. I have a horizontal asymptote at 2, okay? And so here's my asymptote, and this is y is equal to 2. So then, if I graph this on my grapher, it's going to help me fill in the curves. Okay, so let me put this in. We'll let our calculator help us, and then we'll fill in our graph. So our equation is 2x squared divided by, in parentheses, and I'm going to actually enter x squared minus 9. I could have done the plus 3 and the minus 3, but that's really just for my benefit. And I'm going to graph. Okay, there's the negative 3. Oh, lovely. Okay, all right. So I'm going to scoot this down here, and then I'm going to add this information to my graph. I have a branch here, and I have a branch here, okay? And then I actually have a point of intersection here, and there's that, okay? So now I'm actually going to find and verify my x-intercept. So my x-intercept comes from the numerator, so I set 2x squared equal to 0, and I solve, so I get x squared is equal to 0, so x is technically plus or minus 0, but we really don't have a negative 0, so I know that my x-intercept is 0, okay? All right, and that's what we got to see on our grapher. My y-intercept, remember when I find the y-intercept, I let x equal to 0 and I solve. Well, if I let x equal 0, I'm going to get y is equal to 0 over a negative 9, and so I get 0. So my x and y-intercept both are going to be at 0. All right, so now all I have left to do is talk about my domain and range. So this one's actually a little bit unique because my domain, red left to right, I'm going to go until I hit a negative 3, I have a break. Then I go from a negative 3 to a positive 3, I have a break, and then I start at 3 and go to positive infinity. So I'm going to write that as a negative infinity to a negative 3, unioned with a negative 3 to 3, and then unioned with 3 to positive infinity. So this tells me that I have pieces of the graph in all three of those intervals. My range, I'm going to start at the bottom and go up. Notice that the 0 is included, so my range is going to be from a negative infinity to 0, the 0 is included, and then my graph starts again above 2, the 2 is not included, and it goes to positive infinity. All right? Okay, So now let's do another example. Okay, so scoot my paper up a little bit. This time our equation is going to be y is equal to 3x squared over x squared minus 1. So the first thing that I'm going to do is I'm going to factor x squared minus 1 to be x plus 1 and x minus 1. Okay? So I know that my vertical asymptotes are going to be x is equal to plus or minus 1. The degree is the same from the bottom to the top. So my horizontal asymptote is going to be y is equal to 3 divided by 1, which is 3. Okay? What's the next thing that I have to do? So the next thing that I'm going to find are my x-intercepts. Okay? So my x-intercept comes from the numerator. Okay, so I'm going to set 3x squared equal to 0 when I solve, and so I get x is equal to 0. And that's going to be my x-intercept. My y-intercept, I let x equal 0, and then I solve. So if I go back to my equation, I'm going to get y is equal to 0 over a negative 1. So I get that my graph is going to go through the origin again. Okay? So now I'm going to put on my asymptotes, and then I'm going to use my grapher to help me find the curves. So I said that I had a vertical asymptote at 1 and a negative 1. Thank you. So I'm going to draw my two asymptotes in there, okay? And I always need to be able to read your numbers. And then I'm going to put on my horizontal asymptote at y is equal to 3, okay? And I know that I have an x-intercept of 0 and a y-intercept of 0, so I know it's probably going to go through the origin, but I don't know exactly how. So let's put this equation into our grapher. Maybe you can see it. And my equation was 3x squared divided by parentheses x squared minus 1, and I graph. And my graph is going to be actually very similar to the one we just did, but it looks just a little bit different. Okay? So I'm going to put that information onto my graph. So I have a curve here, and I have a curve here, and then notice that this guy is crossing right there. Okay, and so then I put my little arrows on. My graph is beautiful, and now all I have to do is state the domain and range. All right, my domain is going to go from a negative infinity to a negative 1. It starts again from a negative 1 to a positive 1, and then it goes from 1 to positive infinity. Okay, so I went from the left and I stopped here. I started again from negative 1 to a positive 1, and then I start again on the other side and I go out forever to the right. Now let's talk about our range. My range goes from the bottom to 0, the 0's included, so a negative infinity to 0, my 0's included, and then it starts again at, oh my bad, I didn't label my graph, it starts again at 3 and goes to positive infinity. Okay? Alrighty, let's do one more example and then I will give you your problems. Okay? Alright, I'm just going to show you this graph because it's a little bit different, and then explain something a little bit, but we're not going to do much with it yet, but I want to show it to you. So this time I'm going to have y is equal to x squared minus 2x minus 3 over x minus 4. So in this one, I actually want to factor the top. So it's going to be x minus 3, x plus 1 over x minus 4. Okay? All right. So I know my vertical asymptote, I'm going to have 1, is going to be x is equal to 4. Okay? I actually have a higher degree in the numerator than I do in the denominator. So what I'm going to show you is that I actually don't have any horizontal asymptotes, so I'm going to have none, but I'm going to have a cool thing called a slant asymptote, and so it's really going to push M-P-T-O-T-E, A-S-Y. I spelled asymptote really wrong, sorry, A-S-Y-M-P-T. There we go. Now it's spelled correctly. All right, so what I'm going to do first is I'm going to do synthetic division. So I'm going to divide by 4, and I'm going to divide it into 1, negative 2, negative 3. So I'm dividing the bottom into the top, the denominator into the numerator. Bring down the 1. So 4, 2, 5. Okay? So remember, this is my remainder. So I could actually rewrite this particular rational expression to be, this was x squared, so x plus 2 plus 5 over x minus 4. This piece right here is called the slant asymptote, and notice that it's the equation of a line. Okay? So I'm going to kind of sketch this one and show you what happens. So the first thing that I'm going to do is I'm going to graph my vertical asymptote, which is 1, 2, 3, 4. X is equal to 4. Okay? All right, now I'm going to graph my slant asymptote. I have a y-intercept of 2, and my slope is up 1 over 1, so I'm going to go up 2 over 2, and so this is my slant asymptote. And so what actually is going to happen is it's going to push my graph like that. So it looks really cool. So let me show it to you on the grapher. Okay. So if I enter, I'm going to put the whole top in parentheses. So I have x squared minus 2x minus 3 divided by x minus 4, and I'm going to graph it. There's the bottom one. Okay. Oh, and we can't see it. So I'm going to do a zoom 3 enter and zoom out just a little bit. There's the bottom one, and there's my top one. So pretty cool, and that's what a slant asymptote does. Okay? So if I ever have a situation like this one, where the degree in the numerator is higher than the degree in the denominator, I need to do my division, either synthetic or long. The remainder is going to become the new part of the rational expression, and the quotient, this piece right here, this is the quotient, is actually going to become the slant asymptote. Okay, so the quotient is the slant asymptote. Okay? All right, so let me give you your problems, and then we will go over those tomorrow in class. Okay, so the directions are pretty generic. BLEMS. Okay, so there's your problems. I want you to find all asymptotes, and I'd like you to list them on the side like I've been doing in the examples, and then I want you to graph, and then I want you to find the x and y intercept. Okay, and then last I want you to state the domain and range. Okay. All right, you actually only have 3 problems to do because they each take a little bit of time. So your first one is y is equal to 8 over x squared minus x minus 6. The second one is going to be y is equal to x minus 4 over x squared minus 3x. And then the third one is going to be y is equal to 3x squared over x squared minus 9. So don't forget to start by factoring. Alrighty, good luck with your problems, and I will see you tomorrow.